Okay, so as mentioned by Dr. Maria, we have 6 foundational courses lined up in Asia Open Run Academy, and then 3 basic courses, and then 6 advanced courses. And all of these courses will have this framework, starting from the course description, key topics, learning outcomes, learning activities, learning assessments, learning and trainings, resources, and of course, the use of Rakuten Learning Hub. So all of those 50 courses follow this framework. Now let's start with the radio access network. So this is just a glimpse of what you will get in the course. So when we start to discuss the radio access network, so we will welcome you to the world of radio access network, or RAN. So this is where the cutting edge technology meets the airwaves, or the frequencies or spectrum. And the RAN is the backbone of the modern telecommunications, enabling a seamless wireless connectivity for billions of devices around the globe. And then starting from the latest smartphones to the Internet of Things, RAN technology has revolutionized the way we communicate and interact with the world. With lightning fast speeds, high capacity, and unparalleled flexibility, radio access network is the forefront of the digital revolution, and its impact on society is set to grow. So whether you're a tech enthusiast or are just curious about the latest advancement in communications, we encourage you to join us on the journey through the exciting and ever-evolving world of RAN. So the RAN is the one that gives us the mobile network coverage. This is the main reason why you see a signal bar in your phones. And then we built it in different parts of the country. Like for example, what you're seeing in the screen, we put it in different parts of the Philippines. And RAN, next slide, please. Next slide, please, Tony.
Yeah, it's not moving, sorry. My connectivity. Richard, I think my connectivity is the problem. I will stop sharing. Oh, wait for a while. Let me check. There.
Okay.
Okay.
Okay. So RAN is all around you, or the radio access network is all around you. So you can see it everywhere, almost everywhere. You can see it on the roadside, like what you're seeing on the screen right now, in provinces, on top of a mountain, on beachside, on even a rooftop, or even inside your favorite malls. So you can see it all around us, or all around you. Next slide. And in this course, we will also discuss about the different RAN components. So you will be aware, you will be knowledgeable, what are the different components of a RAN. So starting from the radio access network on site, which is composed of the radio remote unit, or the RRU, the BBU, and connecting to the backhaul, or the core networks. So it all starts with the structure, or tower structure, like this, what you're seeing. And then next slide, next. So there's a tower structure, and then you will install the antenna on top. So these are the panel antennas, which is different, functioning at different frequencies, like 1800 megahertz and 900 megahertz. After that, there is a remote radio unit. So these are the remote radio unit, which are also frequency specific. So they function in specific frequencies like 1800 and at the same time the 900 megahertz. And this remote radio unit is connected to the antenna by copper cables. Okay, so, and then from the remote radio unit, it is connected to the baseband unit, where the baseband processing is happening. So this is connected by a common public radio interface, or a CPRI, which is a fiber optic cable. And the baseband unit is enclosed in an outdoor cabinet, which is composed of the power supply and transmission unit. And there's a battery backup as well. So the microwave antenna is shown here in the example, just to show the connectivity to the core network. And then after this, we will go through the future of wireless connectivity, which is 5G. Okay, so where the lightning fast speeds seamless connectivity and limitless possibilities converge. So introducing the 5G system, or the fifth generation wireless technology that sets to transform the way we live, work, and play. With its ultra fast data transfer rates, low latency, and massive devices capacity, 5G is poised to unlock a whole new world of possibilities for industries, ranging from the healthcare to transportation to entertainment. So when you attend this course, get ready to experience the power of 5G and discover how this cutting-edge technology is revolutionizing the way we connect and communicate in the 21st century. So we will discuss what is 5G and why do we need it, and then you will learn the different use cases 5G has enabled the world, from the enhanced mobile broadband, massive machine type communications, and ultra reliable and low latency communications. Okay. And then after 5G, we will have this introduction to Open RAN. Okay, so there's an evolution. There's a long way before we reach the Open RAN era. So we started with the traditional network, in which the site is located, or the equipments are located on site, and it is connected via backhaul network going to the core network. So we call it the distributed network. Okay, so this is the typical implementation of our cell sites nowadays. So this is what we call the traditional network. And then there is a centralized network, or the CRAN, where the CRAN, what changed here was all the baseband unit was put on a baseband hotel. So they pulled the baseband units in one location, in a central office, and then they distributed the radio remote unit, or the RRU, on site. And then from the centralized unit or network, it evolves into a virtualized, VRAN, virtualized network, or a VRAN. So what happens here is the functionality of the baseband unit has become virtualized. Okay, so all the functionality has become virtualized. So there is much more flexibility on the network. So whenever we want to upgrade the capacity, we want to scale the network functionality, we can do it in this virtualized network. But what's the difference of the virtualized network between Open RAN when you compare it? So in Open RAN, it seems like the same as the virtualized network. But the main difference is that each component, or all of the components, are open, specifically the interface. So we can show the Open RAN, Tony, please. Okay, so in the Open RAN, so the interfaces are open, unlike the virtualized RAN, in which the interfaces are still proprietary. And then in Open RAN, we are using a GPP hardware, or general purpose processor, software-defined network, and of course, open interface. So this is the evolution of radio access network. So we will delve in deeper into discussion inside the course. Next slide, please. So what is Open RAN? So Open RAN means Open Radio Access Network. So this is an industry movement that develops a disaggregated, meaning it's a separate functionality, but interoperable radio access network solutions that leverages general purpose processor, hardware, and software-defined technologies, and open interface based on an industry standard. So whenever we implement a new standard, but like Open RAN, we base it on the existing standard like 3GPP. And there is a new standard that is being used, the ORAN Alliance. So there are new standards created by ORAN Alliance, and there is an existing standard that is being adapted from the third generation partnership project. Okay, so that's the glimpse of the RAN, 5G, and the Open RAN. And now I will hand over you to Josel Reyes to discuss about the deep dive into O-RAN architecture. Yasil.
Hi. Thank you, Richard. Can you hear me?
Yes.
Yes. Thank you, Tony. Okay, so for the other course on Open RAN, we have deep dive into Open RAN architecture. So this particular course is created by yours truly. I'm Josu Reyes from UST and one of the course co-creator of IORA. So for this particular course, we'll be covering more on the theoretical aspects of Open RAN, particularly the architecture. So later, actually, I'll show you a spoiler, which is the architecture of the Open RAN. Okay, so yes, okay, so just to compare first, we have the 3GPP design on the left and the O-RAN design on the right. For the 3GPP design, you'll see that there are three main components for the RAN, which is the radio unit, the distributed unit DU, and the central unit CU. But in this case of the O-RAN architecture or the overall architecture of O-RAN, you'll see that there are additional interfaces and additional blocks. Like in this case, there is now a mid-haul between the DU and the CU. And also there is what we call a near real-time RAN intelligent controller or NRT-RIC, which is going to be discussed further in another course. So let's first just go into this architecture. Okay, so next slide, thank you. Okay, for the O-RAN architecture, this is the main or important slide for the course. So just to give you an overview, there are different parts like the SMO, the Service Management and Orchestration Framework, which also houses what we call the non-real-time RIC. And then this SMO and RIC is connected to other components of the architecture. Like for example, the near real-time RIC, the O-RAN CU or O-RAN centralized unit, and then also the O-RAN distributed unit or open distributed unit, and the open radio unit, and also the open clamp. Okay, so the main idea of this architecture is to show how the different blocks or how the different functional blocks of the O-RAN architecture is interconnected and what are the important interfaces that connects them. So for the RAN part, that includes the near real-time RIC until the ORU. And of course, there are other RAN components, like for example, the OE node B on the left side. This indicates that there is a separate node B that is also being managed or being overseen by the SMO. Okay, but we'll go deeper into this once you are able to have access to the course. And then the other course that I also created would be about the RAN Intelligent Controller, or this is more commonly known as RIC. So the key topics are listed here, but mostly these are going to be discussed in the course. Okay, so next slide, please. Yeah. Okay, so this is another way to look at the O-RAN architecture. So this is here is the SMO again, the non-real-time RIC. When we say non-real-time RIC, these usually considers services or applications that run more than 1 second of the time. So it's not really real time. For example, there are traffic forecasting, machine learning, training of the model to improve the whole system. Then for the near real-time RIC, this is mostly for the management of the RAN. That means these are the tasks that require less than 1 second of latency. So these are mostly for management of the CU, of the DU, and the RU. There are actually more information in the course. Like for example, on each block, there are other smaller blocks inside, but this is just to give you a taste of this course. Okay, maybe the last slide, Tony, or rather the next slide. And in addition to the RAN Intelligent Controller, this particular course will also cover what we call the functional split, which is an important aspect for mobile operators. So since the Open RAN introduces a lot of interoperable interfaces. They also are able to offer flexible options on how they plan to deploy their RAN. So they're not limited to the traditional setup like the one on the left, wherein you have a monolithic RAN, you have a radio unit and a baseband unit in one big block. In the RAN functional split for this Open RAN, you can further subdivide it into a distributed unit and a centralized unit. And each part of this is assigned a certain layer of the OSI model. And the mobile operators, the vendors can decide how to split the functions. So it's not necessarily just the CU only manages a certain part. It can also be customized to manage other applications or other functionalities. This is brought by the concept of the open and the virtualization of the different software. Okay, so I think that's all for my two courses. So back to you, Tony. Thank you.
Raymond, actually. Mon.
Okay. Yes,
Yeah.
hello. Yeah. So good afternoon, good morning, everyone. So for the cloud computing, this one is discussion and briefing on cloud technology, and next slide, Tony. Discussions on terminologies, implementations, like what is software as a service, and what is the difference between the other platforms, like infrastructure as a service or platform as a service. And of course, we also want to impart on our students and stakeholders on what are their choices available. Is it really just subscribe to a vendor, or you could actually build your own? Like on the next slide, we could even host your own private cloud, but yeah, you'll have to basically check out yung cost and benefit of creating your own cloud or doing with the public cloud. Or on most organizations that we've encountered, and most likely this is also what's going to happen on telcos, is we're going to have a hybrid cloud environment wherein you mix based on cost and benefit ratio, of course, instances on public cloud like AWS, Google Cloud, or Azure, and then those components that needs to be near the radio access network that's going to be part of your private, and then you interlink them with what we call a hybrid cloud. Now, that said, there's also a lot of misconception with cloud computing, even though it's very ubiquitous nowadays. No? So in the next slide, sample here is we'll discuss yung security considerations for security in the cloud. No? It's basically a shared responsibility model, and we always get this issue that customers, organizations think that if they move the infrastructure to the cloud, they're going to be secure. Well, in fact, the vendors are only securing it based on what is within their control. And as an example, this is taken from Amazon. The customer data, the OS, especially for EC2 network fiber configuration, that's still on the side of the client. And on the event that there is a breach, that would entail that is it really so the entry point really did came from the customer's responsibility, or is it an issue with the vendor or particular responsibility? So that this should enable our students and organization to be able to determine what level of security and resources should be able to throw into the cloud computing component of Open RAN, and ensure, of course, the security, since this is going to be part of critical infrastructure. Now, for my next course, it's going to be edge computing. This one is a discussion on there is a movement to the cloud, shifting our workloads in the cloud environment, but there are issues again with cloud computing that is not solved. So there are issues with that kind of infrastructure that's not solved easily, like latency. We can't beat physics basically, and there are components and operations that needs processing power to be near those IoTs or sensors, so that they could decide on their own and maybe just report their status to the cloud for a central view of the organization. So there are advantages and disadvantages, and we want to determine use cases on where these are applicable and what kind of technology should be able to benefit on this type of environment for edge computing. So it's not just moving everything to the cloud. It's now, could we actually bring back some of the computing power? And some of those use cases, next slide, Anton, are 5G software-defined networks that they could decide on their own. Of course, they need a central controller for it. But for real-time and responsiveness, you want some decision-making capabilities on the edge devices. And of course, processing for AI and machine learning for smart devices enables them to process it and not burden the cloud component or the central component of the infrastructure. Okay? And then again, just report the status if it's a fail, if it's an ongoing, or if it's successful processing to the central or usually it's the cloud core computing environment. And yep, we'll also, of course, since these are not technically competing technology, but two complementing technologies. On the next slide, Anton, we want to differentiate how are they different, yung cloud computing versus edge computing, and how are they similar, and the issues and fixes now we want to be able to consider when deploying cloud computing and edge computing infrastructure. I'll be back next, but now I'll turn over to virtualization. Thank you.
Liberius.
Hi, everyone. Good morning. So I'm Liberius Inutaruk. You can just call me Liber. I'm under Globe Telecom, and I'm also a part-time instructor at FEU. From what was discussed in Open RAN, edge computing, and cloud computing, the course that we would be discussing now would be an application specifically of cloud computing and edge computing. Meaning that from the perspective, because most of the use cases that we have right now for cloud computing are mainly driven by the requirements of IT-based applications. Now, coming this or putting this into the perspective of Open RAN in telecommunications, we're now going to apply it using network functions that can be used in a telco environment. This is now where the course would come in. Now, we would be tackling in this course two specific technologies: software-defined networking and network functions virtualization. Now, what I'll be showing you here are just a glimpses also of what would be the main meat of our discussion. But first off, we have to define first what is SDN in NFV. Think of if in Open RAN and RIC, as what was discussed a while ago, the focus is more on opening up the radio access network, specifically the core services that are running our wireless broadband technologies, such as packet core, voice call, among others. Originally, when we are deploying our core network elements, we can even state them as network functions. They are usually deployed by our vendors in a monolithic architecture. Now, when we say monolithic, it just means that whenever we purchase services or whenever we want to introduce a new service to our wireless network, it would normally be associated to a given hardware and software licenses, and everything would have to be purchased by or from a single vendor. Now, NFV and SDN tends to change that one because we want to introduce the level of openness to our telecommunication operators. We want to also empower them to give them more leverage in purchasing what is just needed for them to avail of a given service. Now, this is where SDN and NFV would come in. Consider SDN and NFV as sort of like an application or a use case of your cloud computing, wherein if say I want to deploy a GGSN, which is a gateway network that will be serving our packet services for 4G, or even a UGW for our 5G service, instead of purchasing the entire hardware from one specific vendor, I can just pick and purchase, say, a specific software from one vendor and use servers coming from commercial off-the-shelf hardware to host that given network function. Now, this is not just a matter of decoupling um, um, the hardware and software altogether. We're also introducing here another concept called orchestration, which is essentially the glue that sticks all of the okay. Now, this is just a glimpse of what we would be discussing for this course. Apart from also network functions virtualization, we would also be discussing what's called SDN. Now, in the next slide, I've introduced to you here, or we would be discussing here some keywords and terminologies that you would be encountering when we are already talking about SDN and NFV. So we now know that SDN, this is more of an IP-based technology, but in the context of network functions virtualization, we're now giving this a fresh use case or application specifically to our telco. Okay, so SDN as a technology, this is a enabling technology that decouples the control and network forwarding functions. Essentially, we are configuring already switches so that it can serve already traffic for our wireless network. Okay. Now, for us to enable SDN, we need to have the protocol. Now, one of those protocols is what's called OpenFlow. Now, this is the very first standard communications interface protocol that is used to implement software-defined networking. This is not just to say that this is the only one that's available nowadays, but consider this sort of like the backbone protocol for all other protocols that can be used in SDN. So more of that one once we discuss our course. And finally, going back on the use case for NFV, network functions virtualization. This is also a technology that enables or decouples network functions from dedicated hardware. So more details of which would be discussed in the course. And in our next slide, we'll also be discussing here. Hello? Hello?
Yeah.
There. Okay. Yes, Tony. Sorry.
There is noise. Richard, can you assist Liber for to minimize his noise, please,
Okay. Wait.
while waiting?
Hello. Is that better?
Yeah.
Hello.
Yeah,
Is that
that's
better? Okay. Okay. Good. Okay. So in another topic that would be discussed for our course would be the interrelationship between SDN and NFV. Essentially, these are two technologies that are correlated together. Now, in the bigger picture, once we start deploying network functions in our network, NFV would be responsible for ensuring that the different components can actually be spread across multiple data centers. And the one who is able to essentially glue all of them together to form the network service itself, that is where SDN would come in. Now, more details of these two technologies and how they are interrelated together would be discussed. And for that one, I'll turn over to Raymond to discuss AI.
Okay, I'll take this, Liberius. Thank you.
Okay,
So
thank
for
you.
the artificial intelligence in Open RAN, so let's have a quick recap. How do we open the radio access network? So first, we need to have a general purpose processor. We will use a general purpose processor. Aside from the proprietary hardware that we currently get from the existing vendors. Next, we do the software-defined network. We will implement that in our system. And of course, we will open the interfaces. So the connections between those equipment and those hardwares will be open. And the next thing, one of the most important and interesting thing also in Open RAN, we will put intelligence in the network. So when we say put the intelligence in the network, we will put exactly the artificial intelligence, which has the potential to transform many aspects of open radio access network. So there are some ways in which AI could be used in Open RAN. So where do we activate the AI? As mentioned by Josil a while ago, this could be located in the RAN Intelligent Controller, or the RIC. So there is the near real-time RIC and the non-real-time RIC. So later in the course or in the future, we will be discussing how AI will help the Open RAN. So just to mention a few, so it will be used to have the predictive maintenance. So there's an AI algorithms that can be used to predict the potential equipment failures in Open RAN infrastructure, so that it will allow operators to proactively address issues before they result in service disruptions. Next is network optimization. Artificial intelligence can be used to optimize the performance of Open RAN networks by analyzing data from network equipment and user behavior to make a real-time adjustments to improve network performance and coverage. Another thing is self-organizing networks, or the SON. AI can be used to create a self-organizing networks that automatically adjust to changing conditions in real time. Like for example, in the V2X, the vehicle to everything, where moving cars are talking to each other and adjusting all the parameters while they're on the move. So this can help operators to reduce the time and resources needed to manage their Open RAN networks while improving overall network performance and coverage. And last thing is network security. So AI can be used to detect and prevent security threats in Open RAN networks by analyzing network data. AI algorithms can identify potential security breaches and take action to prevent them. Okay, so next slide would be just to show the overall. AI has the potential to enhance the efficiency, reliability, and security of Open RAN networks. And it's likely that we will see more and more AI-powered solutions emerge as Open RAN continues to evolve. So more about this in our course inside the academy. Okay, next I'll hand over back to Mon for the interoperability.
Thank you, Richard. So, good morning again, everyone. This one is for interoperability. We want to be able to determine, since Open RAN components is going to be broken into smaller pieces than the usual one big vendor environment. We want to test basically and find out how does different vendor would interact if they're going to be deployed to different parts of the Open Radio Access Network. Now, that said, the previous generation of telecom networks, it's usually one vendor solution. And this would entail, at least for Open RAN, there would have to be discussions on interoperability. So actually on the next slide, we have a huge chunk of our discussion on this course would be challenges. Aside from defining the APIs and interfaces, what would be the challenge if you're going to be part of the Open RAN ecosystem? And well, of course, there's a lack of standardization, which Open RAN is trying to solve to be able to have each and every component communicate seamlessly, and could be replaced depending if a certain vendor A has a more value proposition for the telecom operator. And since this is multi-vendor environment, of course, the integration complexity also plays a factor, a huge factor for that matter. So now they need to have a test environment where they would have all of these components on a smaller scale to be able to test if it really does work and up to spec based on the documentation that the operator received. And with regards to that, aside from integration, it also goes hand in hand with the testing. environment, where there are different use cases on how to test these components. And what we'll do is there is a big open run testing documentation that's still a live document. It's being um, modified as we speak. We'll sample some of their best use cases for testing some components. So we'll have an idea on how this interoperability and testing comes into play. And of course, there's organizational issues on interoperability, again, especially involving different vendors. Some are the competitors, but most of them will be competitors anyway. They did encounter, in networking environments where vendor A would say they are compatible with certain standard, and also vendor B comply to that certain standard. But when you have them talk to each other, they have their minute differences on the implementation that makes it impossible for these two components to interoperate. Hence, interoperability is a huge discussion on OpenRun. So now for the next one, OpenRun use cases, turn you back to Richard.
Thank you, Mon. Okay, for the Open Run use cases, so this is where you will experience or you will learn about the different applications and use cases of Open Run in the industry. So basically, we have two use cases phases suggested by the ORAN Alliance, which is one of the policy and or the specifications, creators of the Open Run system. So we have this phase one, which is including the low-cost run white box hardware. So you will also have this traffic steering. So you will try to balance the traffic from one cell site to another cell site. There is what we call the quality of experience optimization. And we have this massive MIMO optimization. So how Open Run using the artificial intelligence machine learning use that technique to balance or to optimize the massive MIMO. And of course, the quality of service-based resource optimization, in which you are balancing the resources from each user using the artificial intelligence machine learning techniques. On the phase two, there is a run sharing, in which every operator or different operators can share the radio or the software that is installed or on the cell site. So that's what we call the run sharing. And then there is also the run slice service level assurance, context-based dynamic handover management for the V2X or vehicle to everything. And of course, in the rise of the UAV or the unguided aerial vehicle, or AKA drones, that will be controlled by Open Run or radio access network. So there is a flight-based dynamic resource allocation, and at the same time, there is a radio resource allocation for UAV applications. So those are some of the interesting applications that we will study in the Open Run use cases in the phase one and phase two. Okay, going back to Mon about Open Run and security.
Thank you again, Richard. So for Open Run and security, so I think this is my main course. We'll have discussions here on Open Run security, since this is a critical infrastructure. Security would be top of mind of the designers. Now, unfortunately, this is still a work in progress, and what we do have for now is some specific frameworks that Open Run is recommending, and which we're going to be discussing, like NIST cybersecurity framework, Center for Internet Security, Critical Security Controls, among others, which helps assess and implement controls to further secure Open Run and deployments. And a huge chunk of this would require security testing. Aside from the design, it's going to be dependent on the vendor. When you try to integrate a component to Open Run, you want to ensure its security. Hence, we'll be discussing simple vulnerability assessment per component, how to conduct it, what tools to use, what are the pitfalls. We'll also teach here how to do a lockdown of certain equipment. Like we have a lab here for, let's say, if you want to deploy an Ubuntu virtual machine, what's the proper way to deploy it securely, and what are the configurations needed to lock it down in compliance to CIS benchmark for that specific Ubuntu VM. So That said, though, there would be a requirement for this course, or that you need to be familiar at least with Linux operating system, since a lot of the Open RAN environment would be running on it. Next is, well, a big component, of course, of Open RAN security would be the threat modeling, since they don't want to be, it's for Open RAN, they haven't been specific to what type of security implementation that they want, since a lot of frameworks. So for us to determine which component would have high exposure and what are the threats against it, no? And what could the attacker do? Discussions also on what kind of controls could we implement. Okay? And at the end of it all, we would now do risk assessment to consider a certain type of exposure as high, low, or medium risk after this one. Then for my last course, this is going to be value chain. And we want to, of course, differentiate value chain versus supply chain. So they are interrelated, but must end-to-end value chain. So from customer, innovation, design, development. So again, looking at here, the customer would have input to the development until this device and equipment gets delivered to you. And of course, the sales and customer service towards the lifespan of the environment is also put into consideration. Now, Open RAN value chain, on the next slide, we have a lot of categories, from services, hardware, cloud platforms, semiconductor, software, and development. We have some studies that we're gonna pick apart, and determine which of these components would have a good outlook revenue-wise in the next 5 years, and which companies basically are having their R&D and manufacturing also funds being allocated specific to these categories. And for that, we'll know and determine for ourselves how Open RAN would proliferate in the near future, and basically how they would penetrate various telecom operators for future-proofing our communications in the future. Okay, so next would be policy consideration.
Good morning, everyone. Basically, this is one of the webinars we conducted last this first Saturday of September. I'm sorry, of October. It was delivered by then Dr. Laliana. So technically, what we are implementing here, or what we would like the government to implement, is to adopt a government whole approach. And this has been advocating by the ICT since 2012, when we did the iGov field project and the National Government Portal project. As for the legislation, we are requesting for the NTC to reorganize, as Dr. Laliana would put or said in his webinar, and as part of the research paper that they had conducted, the NTC at the moment still organized following the pre-internet era. Of course, when it is reorganized to serve the requirements of today's technology, not just Open RAN, then we can support open access and strategic spectrum management. As mentioned by our previous speakers, Open RAN would help avoid vendor lock-in, while encouraging, of course, vendor diversity. Right now, we have the UK government who is spearheading by developing the principles in Open RAN, such as open disaggregation, a standards-based compliance. That's why we have the 3GPP, and we also have the open the use cases, as Richard mentioned, in the managing Open RAN use cases. It will also demonstrate interoperability as well as implementation neutrality. At the moment, there are 4 eyes, and that includes Australia, Canada, and the US, that is backing up these UK principles for the development of Open RAN. So basically, it will be a clear signal to telecoms firms across the globe about how the 4 countries would like to see the benefits of Open RAN realized. For the resources, I would call on our friend from Rakuten, Yoni. Dr. Yoni.
Yeah. Good morning, everybody. My name is Yoni Leiden, and I work for Rakuten Mobile. Can we go to the next slide, please?
Yeah.
Great. And I won't go too much into the details on usage of the platform. We'll reach out later to people who will register. What I want to say first is that since we're utilizing a platform for this that is originally developed for our internal use, some of the security policies are a little bit harder than on some other platforms. And one of them is, of course, that we'll invite, or basically Open RAN people will tell us who to invite. We'll invite you. Once you register, you'll need to have Google Authenticator installed on your phone to create the secondary authentication method. And using that, then you'll be able to get access. Also, some of the rules, tighter security rules mean that if you don't log in once a month, your account will get deactivated and you'll need to reach out for support to get it reactivated. Can we go to the next slide, please? So once you log into the platform, this is basically the page that you would see. There's some of the ORA courses that have already been mentioned previously during this webinar. There's also some Intel courses that we're working to add there right now. Can we go to the next slide, please? And just to highlight a little bit more of the features that the platform has. So especially now that we have very nice course creators here on this call, if you go to the specialist channels section and you find, for example, please go to the previous slide.
Okay, sorry.
Yeah, thanks. So in this section, you'll find all of the trainers who have created courses. And basically, if you find that, oh, Jossel's previous course was really, really good, you can basically follow her from here and be notified anytime she creates a new course. And from here, you can easily access all of the other courses that have been created by those specific creators. Can we go to the next slide, please? Thank you. And I think especially for the students side of this webinar, I think this should be much of great interest. So we also have communities, and here you can then discuss, for example, the courses that you've taken. If you have any questions, if you want to share, for example, videos, if you want to basically post, what did you think about the course? This is basically your internal social network for the Asia Open RAN purposes. So this will be a very nice place for you to share ideas on the courses, share feedback, and create communities for some more specific niche purposes that you might ever had. Or if you want to create even on a course basis, you can create communities for those discussions. But as I said, well, ORAN will share some more instructions on how to access the platform a little bit later. That's it from my side. Thank you, everybody, and I'll